Hello everyone, nice to see you again. In this video, let's introduce some technology of cloud computing.
The first one is container. We talked about the history of virtualization. The container is a lightweight virtualization technology. The so-called lightweight virtualization is the use of an operating system virtualization technology, which does not belong to our Type 1 virtualization, now Type 2 virtualization. This technique allows the user space on an operating system to be split into several separate units, and then run in the kernel without interfering with each other, such that a separate space is called a container. The container was originally based on LXC developed by Linux, but now the most talked about container is Docker. Docker is an open-source application container engine. It allows developers to package their applications and the application's dependencies into a portable container, and then publish it to any popular Linux machine, as well as virtualization. The container completely uses the sandbox mechanism, and there is no interface between them. The biggest difference between a container and a virtual machine is that the guest OS is included in the virtual machine. The container is just in the host OS, and then adds a Docker virtualization engine in the middle. Going up is the application. Basically, each container does not contain the operating system of the host. Since the container does not contain the operating system, its capability is generally much smaller than that of the virtual machine. The virtual machine starts up slower than the container because it first starts the guest OS inside. In terms of integration, the virtual machine is also a little worse than the container, but the virtual machine has some advantages that the container does not have. In the era of cloud computing 3.0, we use more containers. For example, the LCX, Docker, and so on. In the 2.0 era, we use OpenStack more. OpenStack was originally launched by NASA and Rackspace. After the open source, it got the Apache license. OpenStack is a cloud computing operating system. Speaking of the operating system, when we usually use the PC, our operating system is Windows. When you insert a USB flash driver or a mouse and keyboard into the PC, the first thing is to load the hardware driver. Only by mobilizing this driver, you can use this plug-in, your U-disk, this mouse, keyboard, and so on. In the OpenStack, since it's an operating system, it also needs to be smaller to driving these things to call the underlying resources. In OpenStack, this driver is called a component, and there I have 9 key components. These 9 key components are only part of the whole, not all. For example, we will use Nova to call the underlying computing resource to provide computing service. Call the object storage through Swift. The sender calls the resource of the block. Neutron provides network service and more.
Okay everybody, we just briefly introduced the container and the OpenStack here. There are 2 directions in the latest version about HCIP cloud computing specifically for the OpenStack and the container. If you want to know more, please pay attention to the new released by HCIP. This is the last video about this chapter. We will introduce a few emerging technology of cloud computing.
After years of development, cloud computing has basically matured, but objectively, there are still some issues to be resolved. For example, network congestion. We have a process when we set big data. We need to transfer this data to the cloud computing data center. The process of this transmission may be delayed due to the congestion of network. and the timelines of big data cannot be met. Another is the problem of high network latency security. Since the problem occurred in the process of this transmission, then we simply don't let it come back. It is good to know where the data is generated. So cloud computing has extended two new technologies, one called edge computing and the other one called fog computing. First is the fog computing. The fog computing refers to the addition of a layer between the place where the data is generated and the data center. This layer is called the network edge layer. For example, here is a small server with a memory or a router, and some data that does not need to be put into the cloud is directly processed and stored at this layer. This can alleviate the pressure of the cloud, but also improve the efficiency, but also increase the transmission speed and reduce the delay. This working principle is actually equivalent to fog computing. Compared with cloud computing, fog computing is more grounded. The focus of cloud computing is on the way in which calculations are performed. The fog computing emphasized the location of this calculation. Fog computing is closer to the ground than cloud computing, and their location in this network topology is different. There are many similarities between fog computing and cloud computing. For example, they are all based on virtualization, providing resources for multiple users for a shared resource pool, and so on. This is the fog computing. And then let's look at the edge computing. Edge computing is different from the traditional centralization thinking. Its main computing nodes and applications are distributed in the data center close to the terminal, which makes the response performance of this service higher concept than traditional centralized cloud computing. In particular, edge computing can be understood as use of the edge data center near the data source to complete the calculations process. Applications that apply edge computing such as some games, IoT, and smart home, as well as a video of ultra-high definition images, surveillance system. For cloud computing, it includes our internal service, web search, and more.
By convenience, we have two short questions here, one about AI and one about IoT. We will talk about this in this issue. Let's make a summary here. In this section, we first introduced several ideas related to cloud computing. In addition to visualized, there are some technologies which are used into cloud computing. Finally, we introduced several emerging technologies such as fog computing and edge computing. The full content of HCIA Cloud Computing is finished today. Welcome to leave a message to us on official channel. Any technology questions, or opinions and suggestions, I hope that you will leave a message. Thank you. Bye.